Alright guys, so today we are going to be going over slope-intercept form. And slope-intercept form is a way of writing functions that helps us graph linear equations. And now most of you have already seen this first page, but what we're going to be looking at first is identifying the slope and the y-intercept. And so the slope is going to be everything after this equal sign and before the x. So we're going to call the slope m. So m is the slope. And then the y-intercept is the other part that we are looking for, and that is going to be everything after the x, which includes the sign in front of the b. So b is the y-intercept. So if we look at this next couple examples, it says write the equation of a line given the slope and the y-intercept. And so what we're going to do is put it into taking the m and the b and put it into this y equals mx plus b form right here. So we have slope is -2. So m is -2. And a y-intercept of 5. So that makes b equal to 5. And now all we are going to do is put that into the spots. So y equals m, which is -2, x plus b. And since our b is positive 5, it's going to stay addition. So y equals -2 times x plus 5. So looking at this second example, it says slope is 3/4. So that makes m 3/4. And y-intercept, which is our b, is -3. So b is -3. And so with this one, we're going to have y equals 3 divided by 4 times x. And instead of an addition, since our b is negative, this is going to become a subtract 3. So that's how we write the equation out if we are given the slope and the y-intercept. We just put them into the spots where they belong. We substitute them in to where they belong. So now let's take a look at what we would do if we are given a graph. So pardon my pencil drawings here. I am using just a mouse pad, the notepad. But first we would find our slope, and we know how to find the slope on a graph. We're first going to draw that vertical line up, and then we're going to draw that horizontal line over. And I can count from my first point on my left, 1, 2, 3, 4. And then I will count over, and I get 1, 2, 3. So the slope becomes 4 divided by 3, or 4/3, and that becomes our m. And then our y-intercept is going to be found by locating the point that is on the y-axis right here, and this is our point right here at 0, -5. And when looking at the y-intercept, we only want the y value when x is 0. So our y-intercept becomes -5. Now that we have our m and our b, we can rewrite the equation to y equals mx plus b, where y equals 4 divided by 3 over, or 4 over x, I'm sorry, y equals 4 divided by 3x minus 5, or y equals 4/3x minus 5. Looking at the next example, our furthest left point is here. I'm going to draw down 1, 2. I draw over 1, 2, 3, 4. Now as you see there, I counted as I drew, but we can double check. 1, 2 down, and 1, 2, 3, 4 over. And now I end up with a slope of negative 2 over 4. And then remember, we always simplify or reduce those fractions. And when I reduce negative 2 over 4, I end up with negative 1/2. Now looking for my y-intercept, I find that point that is right here on the y-axis. And I'm going to look at the y value. And that point's already given to us. The y value of this point is 1. So my y-intercept is 1, or my b is 1. And now rewriting the equation, we want to make sure that we use this right here for b, this one right here for b. That is our reduced slope. We use our reduced slope when writing the equation. So y equals negative 1/2 x, and 1 is positive here, so it's going to be plus 1. All right. If you need to take time to get all of this copied down, just go ahead and pause the video right now and make sure that you get it all written down. All right, so here are a couple examples. I want you to go ahead and give these two a try. If you're having trouble with the 2 points, I will help you on this second one. The 2 points that you are looking for are here and here. Those are going to help you find the slope, the y-intercept, and the equation. So go ahead and pause the video now and work through these 2 examples. Alright, so looking at this first one, we would find the slope by starting at this leftmost point, drawing our line up, and our line horizontal, our vertical and horizontal lines, and counting them out. We went up 1, 2, 3, 4, and we go over 1, 2, 3. So we end up with a slope of 4 over 3 again. And our y-intercept is sitting right here. And if we look, since we know the x is at 0, the y-intercept would be at 1 up, 2 up. So the y-intercept is going to be positive 2. So now we're going to put that into our equation with our slope, or m, of 4 over 3 and our y-intercept of positive 2. So y equals 4 divided by 3x plus 2. Looking at this second one, I notice right off the bat that when I want to draw my vertical line, I have to go down. And horizontal across. And looking at this slope, I go down 1, 2, 3. Down is going to make that slope negative, and I go over 1, 2. So I end up with a slope of negative 3 over 2. My y-intercept is sitting right here. And so I'm going to check that one by just counting down from the origin at 0, 0. 1, 2, 3. I end up at negative 3 because I counted down. And I have the wrong number there for you. I apologize about that. Let's get rid of that negative 2 and put negative 3 in there. Alright, and so our equation is going to be wrong as well. So I'm just going to go ahead and write that out. It is going to be y equals negative 3 divided by 2x minus 3. Alright. So looking here, we're going to be looking at how to find our slope. This is something that you guys have already done, so I expect you guys to be able to work through these on your own. But to help you out, I want to make sure that you see we're going to be choosing an x1, y1, x2, y2, and the points are going to be linked together. So when I pick, I'll pick this point here. This one becomes x1, y1, And then if I pick the next one right below it, this one would become x2, y2. So now I'm going to put that into my formula of y2 minus y1 divided by x2 minus x1. And so I get negative 1 minus negative 3, which will become an addition, and negative 1 minus negative 2. And when I work through those, I end up with 2 over 1, and we always simplify, so the slope here ends up being just 2. So let's look here. Again, I start with my x and y. And it doesn't actually matter which ones we choose here, but I get an x1 and a y1. And then I chose, if you notice, I skip one here. And I'm going to choose this point here. We'll end up with the correct slope no matter what 2 points we choose. We just might have to do more simplifying when we separate them by further distances. So now I set this problem up as m equals 4 minus negative 2 and 0 minus. That is not set up correctly. I apologize. I've been working on this very quickly. Let me get this out of the way and fix it up for you. So this will be 4 minus 3, and this one here will be 0 minus 2. And when I do 4 minus 3, I end up with 1, and 0 over negative 2, or 0 minus 2, I end up with negative 2. And what I'm going to do is equal that out. I'm going to put the negative sign in front and do 1 divided by 2. I'll check to make sure that that simplifies correctly. But I will let you know that that definitely does simplify down correctly. So our answer will be negative 1 over 2 for the slope here. Looking at this last example, let's see if I can get this one right. We have x1 and y1, and x2 and y2. So I should be setting this up as 14 minus negative 16 and 5 minus negative 5. It looks like I finally got one right. And so we're going to do 14 plus 16 actually, and 5 plus 5. We're going to end up with 30 over 10. And when I do 30 over 10 and I simplify, I will end up with 3. Alright, let's keep on going. See if I can limit my errors here on this one. So looking here, when we were talking about the y-intercept, is when the x equals 0. So if we're given a table and 0 in the x column is given, our y-intercept is going to be the number next to it. So in this example, our y-intercept is 1. In this second example, we look here, we have a 0 again, and our y-intercept is 3. And in this last one, I'm sure that you guys have figured out the pattern by now. I go to the 0, I look at the number next to it, it's negative 1. My y-intercept becomes negative 1. But sometimes we don't have it so easy, and we end up with a table without the y-intercept as part of the table. So what we're going to need to do is solve out for x1 and y1, and use an x2 and a y2. And we'll set those up as a slope, so 15 minus 11 divided by 2 minus 1. When I simplify that out, I get 4 minus 1, and so my slope becomes 4 when I simplify. And now what I'm going to do is put that in to my equation of y equals 4x plus b. And I'm going to pick one of the ordered pairs and substitute in the x and y. And now you have to solve for b, or the y-intercept. So you're going to get your b by itself. So I used 0.2 of 15 and 2. And so I substitute and I put the y as 15. The m was 4. And the x becomes 2. And now we have plus b, and I don't know what b is. So what I'm going to first do is do the 4 times 2. And now I get 15 equals 8 plus b. In working through this problem, I'm trying to get b by itself, so I'm going to subtract 8 from both sides. These 8's end up crossing out. And I end up with 7 equals b. So b equals 7. And so now I can rewrite. And so now I have my slope and my y-intercept. So looking here, we're going to try and put it all together, and we're going to write our linear equation for the table shown. So we want to end up with y equals mx plus b. And our first step is going to be to find our slope. So we need an x1 and a y1, an x2 and a y2. And I just chose random points here just to again show you that it doesn't matter which points I use to find the slope. So I end up putting it in as -2 minus -6 and 1 minus -1. Both of these become addition problems, and I get 4 divided by 2, or just 2. So right here in this spot, I end up with 2. And now, I don't have to do the work extra here. I don't have to solve out, because if we look, I have 0 in the table for my x. If I have 0 in the table, my y-intercept is the number next to it. So in this case, my y-intercept is going to be -4. So now I can rewrite this, and the plus and a minus is going to end up creating a subtraction. So y equals 2x minus 4. Alright, last page of notes here. So we have 2 examples here. I want you guys to go ahead and try these ones on your own. So go ahead and pause the video and give them a try. When you finish up, go ahead and unpause them, and we will look through both of them. So in this first example, we notice that there is no 0, so I'm not going to be able to find b. But first I'm going to find my slope anyway. So I'm going to use an x1, and I just chose this first point and the second point right in a row. And so I end up with, oh, I just gave you your answer on accident. I end up with the slope of 13 minus 5. Please make sure you show the rest of your work here, even if you did not start it. I want all of this rewritten with me, not just the answer. So I get 13 minus 5 divided by 4 minus 2. I end up with 8 divided by 2, and I end up with a slope of 4. And now I'm going to use that slope and plug it in. I used the first point of 5 and 2. So 5 for the y, 4 for the m, 2 for the x, and I don't know the b. So I end up getting 5 equals 8 plus b. I subtract the 8's from both sides, and these 8's cancel out here. I end up with 5 minus 8, which is going to give me a b of -3. And now that I have m and b, I plug that in, and it becomes y equals 4x minus 3. Looking at this second example, I have my x1 and my y1, my x2 and my y2. Now, if you chose different points than me, that is okay. Just make sure that your slope ends up the same. So I come right here and I do 4 minus 10 equals 4 minus 10 divided by 0 minus 2. 4 minus 10 is going to give me negative 6. And 0 minus negative 2 is really 0 plus 2. So I end up with negative 6 divided by 2. Or when I simplify out, I end up with negative 3. Now in this situation, I have a 0 in the x table, which means that I have my y-intercept already given to me. And it's 4 right there. So my problem is done. I'm going to get y equals negative 3x plus 4. And now that we know how to take 2 points or a table and turn it into a slope-intercept form, we can look at how fast we can graph when we have our slope-intercept form of y equals mx plus b. So in this first example, we have y equals 2x plus 1, and our slope is 2, and our y-intercept is 1. And what that's going to tell me to do is come right here on this y-axis to 1, and I put a point. And then what it's going to tell me to do is follow my slope. My slope is up 2, 1, 2, and over 1. And I know that it doesn't show a divide by 1, but all whole numbers, for the sake of slope, have a 1 divided by them. So 2 divided by 1 is how we're going to work that slope. And now I have a second point. And now that I have 2 points, I can take a ruler and I can end up drawing a straight line between the two and creating a graph that goes all the way through from top to bottom. So looking here, we have a slope of negative 2 over 3 and a y-intercept of negative 2. So my first step again is to go to my negative 2 and plot my first point. And now to find that second point, we are going to follow the slope. This is negative 2 over 3, so I'm going to go down 2, 1, 2, and then I'm going to go over 3. 1, 2, 3. And now that I have my points here and here, I'm going to connect them. And I'm going to extend that slope out one more time just so I can connect this all the way out. And we're all set there. Now if we notice, I have more than just these 2 points. I have one right here, one right here, here, and the 2 that we already started with, and one down here. If we notice, they all follow that slope of down 2 over 3, down 2 over 3, down 2 over 3, down 2 over 3. So our slope follows the same movement from one step to the next. Now on this last example, it's a little bit tricky, and we have to isolate the y variable before we start graphing. And to do that, we're going to add 8 to both sides and rearrange our problem. So we add 8 to both sides, and we end up with 4y equals 2x plus 8. And we're almost done, except that we need to divide 4 from both sides and rearrange again. So we divide 4 from each side, and we end up with y equals 2 over 4x plus 8 over 4. And so if you notice right here, I had the 4 over both. Right here, I had the 4 over both. And I separated it out into both 2 over 4x and 8 over 4. I separated them into two fractions. And we can do that whenever a value is being divided by both terms. And now what I'm going to do is I'm going to reduce the fractions and rearrange. So I end up with y equals 1 over 2x plus 2. And now I can identify my slope as the numbers in front of the value in front of the x. So I end up with a slope of 1 over 2 and a y-intercept of 2. So now I come over here and I graph my first point right here. And I'm going to go up 1 over 2. And now if I want to, I can keep just drawing more and more points until I run out of graph. Up 1 over 2. And right here I can only go up 1, I can't go over 2. But I can also go in reverse. So instead of going up 1 over 2, I'm going to go over 2, down 1. Over 2, down 1. Over 2, down 1. And now that I have all those points, I can double check. Up 1 over 2, 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 up 1 over 2. They all connect the correct way. I can now connect them as one line. That concludes the notes for today. Please begin the assignment that accompanies this note packet. If you do not finish the assignment today, that is okay. You can take it home for homework and we will be able to work on it tomorrow in the time that we have. All right. Thanks, guys. Good.